Welcome student, my name is Miraj Ahmed. Today we are going to study the basic of thermodynamics part 4. In this, first we discuss about the energy transfer. We already discussed about the energy transfer by two modes. One is by the temperature difference and one is the boundary phenomena. The first law of thermodynamics is expressed of the conservation of energy principle. It says that the energy cannot be transferred, cannot be destroyed, which can only transfer from one form to another form. Energy can cross the boundary of the closed system in the form of heat and work, but not in the form of mass. Energy transfer across a system boundary due to solely due to transfer difference between the system and its surrounding is called the heats. The work energy can be thought of the energy expended to lift the weight. Here there are two systems which is closed system. First is the rigid system, where in the rigid system the closed constant volume process where the mass is constant, and this you can see that this is a system boundary and the heat is transferred from the boundary phenomena and work also is a boundary phenomena. You can see the second figure, the piston cylinder device. This is constant pressure process. Here you can see that the gas is bounded by the imaginary boundary, a moving boundary, which is so that is the dotted line. First law of flow system. A closed system moving related to the reference plane is shown below, where z is the elevation of the center of the mass above the reference plane and v is the velocity of center of mass. So, this is a closed system and this is a z value from the reference plane and the v velocity of the system. This is closed system. So, when we write the total energy conservation formula for this system, for closed system the conservation of energy principle for the first law of thermodynamics can be expressed as total energy entering the system minus total energy leaving the system is equal to total change in the total energy of the system. The energy input minus energy output is equal to total energy of the system. Closed system first law, according to the classical thermodynamics, we discussed the energy added to be net heat transfer to the closed system and the energy leaving the closed system to be net work done by the closed system. So, this equation you can say that this equation for the process only, the net heat minus net W is equal to total energy of the system. So, the net heat is coming out from the work heat is input to the system and the heat minus heat output to the system. So, you can find the net work done. Net work done is equal to work output minus work input of other system plus work W by the system, and this work W B is equal to the PdV work. Normally the storage energy and total energy of the system explain the sum of the three separate energies: internal energies, kinetic energy and potential energy. So, internal energy can be defined in the terms of U and the kinetic energy can be defined the key in which the velocity should be there, and the potential energy where the height of the system from the reference datum line. The U is the sum of the energy contained within the molecules of the system other than the kinetic energy and potential energy of the system as whole is called the internal energy. The internal energy used depend on the state of the system and the mass of the system. You can also say that according to Joule's law, internal energy also depend on the temperature of the system, function of temperature. So, for the system moving related to the reference plane, the kinetic energy and potential energy are given as the kinetic energy is equal to half mv square and the potential energy is mgz, and this z is the elevation of the system from the reference line. The change in the stored energy for the any system is equal to delta E equal to delta U plus kinetic energy, change in kinetic energy and change in the potential energy. So, Now, the conservation of energy principle, first law of thermodynamics for the closed system resistance has the net heat transfer is difference of net heat transfer minus net work transfer is equal to delta U internal energy plus potential energy and the change in the kinetic energy. If the system does not move, suppose the system is at rest, supposed to be rest with the velocity and has no change in the elevation also. So, this potential energy and kinetic energy should be reduced to 0. So, the equation should be reduced to the net Q heat transfer is equal minus net work transfer is equal to change in internal energy. We will find that this is the most commonly used for forms of the first law for closed system. You can later you discuss about the energy for the closed system. Now we are going to discuss about the first law of thermodynamics for the cycle. The closed system first law for a cycle. The thermodynamic cycle is composed of the process that cause the working fluid to undergo a series of the state and changes through a series of processes such that the final initial are the identical. You can see that the cycle minimum 2 processes should be required and its initial and final points should be identical. The change in the internal energy of the working fluid is 0 for the whole number of cycles. So, the property the cyclic integral of the property of the system is equal to 0. So, you can write the formula of first law of thermodynamics in terms of for the cycle is equal to net change in the heat transfer is equal to net change in the work transfer. Thank you. This is all for today's lecture.